Today we're going to cover mechanical properties of materials, and I believe this is an old exam question. So, the solid tube is 900 millimeters in length and it has a 25 millimeter diameter before being subjected to an axial force of 40 kilonewtons. If Poisson's ratio is 0.344, find the new length and diameter of the tube after loading. So you have this tube and you have some 40 kilonewton force kind of pulling it apart, and they've also given you the stress strain curve for this material. So we have normal stress, normal strain. So I've written down what we know. What we want to find is the new length and the new diameter after being subjected to this normal force, and kind of all of these equations that we know or might need. So the first thing I want to do is kind of figure out what can I do with this curve to help me start my process, because right now I don't have any equations that I can directly plug into. So I start with looking at the curve. So I have a strain or a stress and a strain, and what I can do is I can find E, which is the elastic or Young's modulus, or also the slope of this curve. So I use 450 divided by 0.0225, and that gives me that Young's modulus is 200 gigapascals. Why do I use this curve or this portion instead of this portion? This is the part where the elastic portion, so up until this point, whatever you do to the body is reversible. After this point, after the yield point, once you deform the body, you can no longer return it to its original dimensions. So typically what we deal with is the elastic portion, so we'll be dealing with this portion. So we found E, which is 200 gigapascals. From there, what we can do is find the stress, the normal stress of our body. So I cut the beam or the rod, and at a certain point I find N. My normal force is 40 kilonewtons, so 40 divided by the area, which is pi r squared, gives me a normal stress of 81.5 megapascals. Okay, so now I found normal stress, I found Young's modulus. Now I can find normal strain. So I know the equation for stress, strain, and Young's modulus is this. So normal strain is normal stress divided by Young's modulus. I end up with this number. So once I have normal strain, I know that normal strain is the change in length divided by original length. So I know the original length, I just found normal strain. I can find my change in length. So I end up with delta L, change in length, of my body equals 0.36675 millimeters. So I found delta L. After I found my normal strain longitude, so longitude just means it's along the length. Normal strain latitude typically indicates a change in diameter, a change in width. Width is the way that I like to think of it. So we found delta L, we know what E, or normal strain longitude, is. What we want to do now is find normal strain latitude, and we use Poisson's ratio here in the equation for Poisson's ratio, rearrange it, and we end up with E latitude equals negative 1.4 whatever. So from E latitude, we know that it's change in diameter over original diameter, so we can find the overall change in diameter, and we end up with negative 0.0035045 millimeters. Okay, so up to this point, we found change in length and change in diameter, and we know our original length, we know our original diameter, so now we can find the new length and new diameter. We know that a change in length is L final minus L initial, same thing for diameter. So in the end, my final length is the change in length, which we found, plus my original length. So my final length is 900.36675 millimeters. My change in diameter is, or my new diameter is change in diameter plus original diameter. So negative 0.035045 plus 25 gives me 24.9965 millimeters. So I found what the question was asking for. I found my new length and my new diameter after this tension of 40 kilonewtons on my body. So if you think about it logically, tension, it's gonna end up pulling this body outward, right? So logically, it's gonna get longer and thinner. And that's exactly what happened. Our length increased and our diameter decreased. So it's good that your final answers make sense based on kind of what should happen in theory. Pretty straightforward.